Hi, I'm David Bunn, and I'm going to do a quick video today on how ionic bonds form. And we're going to use sodium and chlorine as our example because it's probably the most common ionic compound that we know. We all experience table salt every day. So first, let's start out with a quick review, though. The atoms that I've drawn here. This sodium atom. Sodium is number 11 on the periodic table, which basically means it has 11 protons in the nucleus. So just to review, this is the nucleus here. And around it are 11 electrons. Protons have a positive charge, as you may know, and electrons have a negative charge. And so in its normal stable, I shouldn't say stable, in its normal neutral state, it's going to have 11 electrons on the outside and 11 protons on the inside in the nucleus. Now, if you notice here, I have 3 different circles around this nucleus, and the basic rule is that these are called energy levels. So each of these circles is an energy level. And this is their orbitals. These electrons spin around real fast in this particular orbit, just like the planets orbit around the sun. And so in this first level, there are 2. That's the basic rule. 2 electrons fill the first energy level. And then in the second energy level, you can hold 8. So if you count these up, there's 1, 2, 3, 4, 5, 6, 7, 8. And then this third level also holds 8. But what you can see here is because sodium only has it has 11 electrons, we've got 2 in the first shell, so there's 2 there, and then there's 8 in the second. That's only 10, so we've got to find a place for this third one. And so it has to fill or go in this last orbital, this last energy level. And atoms don't like that. They don't like to have a partially full, like an almost empty or an almost full energy level. It makes them unstable. It makes them reactive. So sodium is going to be looking to react, and we'll get to that in a minute. But that's our basic setup of an atom here. And then over here we're going to use chlorine. Chlorine's number 17, and it's number 17 because again it has 17 protons. That's just the rule. Whatever an element number is, that's the number of protons it has. So if you change the number of protons, you are changing the atom. The electrons here, again, it's neutral, which means it has the same number of minus charges, negative charges, as it does positive charges. And so there's going to be 17. We're not going to count them all up here, but the same rules apply. First orbital, first energy level has 2, second energy level has 8, and then we have 7 around the outside to make a total of 17. Again, they don't like this. They don't like to be almost full. They're that close to being full, and they're going to be out looking for a way to fill that up, just like sodium over here is going to be looking for a way to get rid of this electron. So basically what happens here is sodium, like I said, is reactive, and so it's going to try to become more stable. And the easiest way for sodium to become stable is to get rid of this electron right here. And so what's going to happen is especially if these two are close to each other, what's the easiest route for sodium to become stable is to get rid of this electron. So what we find happening is sodium will donate or give up this electron. Now, before we go any further, what happens now is if you count these up, you can see that we have a full first energy level for sodium and a full second energy level for sodium. That makes it completely happy. It makes it stable. It's not going to want to react anymore. It has 2 full energy levels. That's good. Now, chlorine over here, though, is still not happy. It still is needing 1 more electron. And so what it's going to do is this electron that was given up is going to come over here and help fill this final orbital. And what they call that is an octet. That just means 8, oct 8. So this chlorine now is happy. All right, so we've taken care of one problem. We've given the atoms what they want. Full energy levels, no partial energy levels. So we've got a full first, full second for sodium, a full first, second, and third for chlorine. Now, something's happened though, obviously. We've disrupted the charge balance. We're not equal anymore. All right, so we have 11 positive charges in the nucleus here for sodium, but we only have 10 negative charges. So if we do some quick math here on this sodium atom, you're going to see we have 11 plus charges, and if you count them up, there's only 10, you remember now, 10 minus charges. So the overall net charge on this thing is going to be +1. So we've created an atom a charged atom, a charged molecule, and that is called an ion. And this particular ion is sodium plus 1, and that is an ion. Now, over here what we've done is basically the opposite. For chlorine, we have 17 protons, so 17 plus charges, but if you count these electrons up now, we have 18 minus charges. So there's a total charge of -1. So we've made an ion now. Now when you make a negative ion, it's going to change the name. It changes the name of this chlorine to, now it's called chloride, but we just still can write it like this: chlorine, chloride, -1, and that's a negative ion. Okay, so what's going on is that we have two opposite charges that are equal in terms of the number of positive or negativity. So if they are close to each other, what's going to happen is, we'll get this stuff out of the way first. What's going to occur is these opposite charges will attract. And you've all heard that term, opposites attract. Well, it's true, and that's exactly what's going to happen here. So if we take this atom, and if they get close enough, drag my electron back over here, this positive charge over here, +1, and this negative charge, -1, is going to cause an attraction. And it's going to be strong enough that they're going to hold each other next to each other. And they form this bond. And it's not as strong as some of the other bonds that you may learn about in chemistry class, but it is strong enough to hold them together. And this is where we get our table salt that we use, and some of us probably use too much. But it's a sodium ion and a chloride ion, and it's called, the name of it is just sodium chloride. And that's table salt. And it forms this nice, neat crystal structure where they're stuck together. And it's the salt that you see on your table is not just these two atoms. It's many atoms stuck together. But it's at the basic structure. This is it, and that's how an ionic bond basically forms.